Okay. So our next chapter on blood, this is the one I'm dressed for. Now we're starting off the cardiovascular system. Blood is actually considered a connective tissue because it's got cells scattered around in a matrix. The matrix is liquid and called plasma. And unlike other connective tissues, it doesn't have any fibers in it. And that's because the purpose of the fibers is to provide structure. You don't want blood to have structure, you want it to flow. The cells are called formed elements. The most common are red blood cells, which some say aren't even technically cells because they don't have a nucleus, but they come from cells. They have most of the other things cells do. White blood cells that do have a nucleus, and then platelets, which are little fragments of cells. The function of blood is transport of gases, nutrients, wastes, even heat. The typical adult blood volume is about 5 liters. Hematocrit is a test used to determine the overall composition of blood. When they take a sample, they put it in what's called a centrifuge that makes the heavy stuff go to the bottom, and that puts all the cells down at the bottom. So another word for this test is packed cell volume, because they're packed down at the bottom. The red blood cells will be at the bottom with a little area called a buffy coat above them that has the white blood cells and platelets. And then what's left is the plasma on top. Hematocrit is the percent of the volume that is the cells or formed elements. An average result is 45%. This is the low end of the range for men, high end of the range for women. So here's what the sample might look like. Without the cells, blood or plasma is yellow, and that's from proteins that are in it. We'll look at each cell type, what they do. Red blood cells are also called erythrocytes, which is Greek for red cells. Their job is to carry oxygen. White blood cells are also called leukocytes. Can someone guess what that's Greek for? White cells, yep. They fight infection. Then platelets are called thrombocytes, which means clot cells. So they are for blood clotting, which is also called hemostasis, which means stopping the blood. Reds, about 1/3 of their volume is a protein called hemoglobin that carries the oxygen, and it has iron in it. Their shape is referred to as a biconcave disc. What that means is it's indented on 2 sides. Bi for 2, concave. So a cross-section of a red blood cell looks something like a barbell. Then the hemoglobin is inside. What makes this shape useful is that it's more flexible than if you had just a round cell, and it gives it more surface area for its volume so that the hemoglobin can be close to the surface where it can easily pick up and deliver oxygen. I have 2 different little cute stuffed versions of red blood cells that I'll send around. this picture. So this picture's from a scanning electron microscope. It takes a picture of the surface of something. So you can see how it's got a thicker outer ring and then thinner in the middle. Hemoglobin has 4 subunits in it. Each one has the globin protein, heme, which is an organic molecule, and then an iron ion sitting in the middle of the heme. The iron is what holds the oxygen. Now on here they've shown the globin in a couple of different shades of purple. And these little Saturns are the heme with the iron in the middle. Sorry. Questions on hemoglobin? Making red blood cells is called erythropoiesis. It's regulated by a hormone called erythropoietin that comes from the kidneys. Erythropoietin is released when oxygen levels are low. So it says, okay, we're not getting enough oxygen, we must need more red blood cells so we can carry more. And if you recall from back in the skeletal system, all of our blood cells come from the red bone marrow. There are cells called hematopoietic stem cells that get stimulated by the erythropoietin to grow and divide and make red blood cells. The cells take about 3 days to develop. So if you've just donated blood, you've lost some red cells, it takes a little time to recover. Too few red blood cells is called anemia, which really just means no blood. A normal count for red blood cells is about 5 million of them in a microliter of blood. To put that in perspective, there are 1,000 microliters in a milliliter, and there are 5 milliliters in a teaspoon. So in a teaspoon of blood, you're going to have 25 billion red blood cells. There's also hematopoiesis, which is more general forming of blood cells. They all start from the same hematopoietic stem cells, which are the ones at the top, and then they kind of specialize into all the different cell types. We've got reds here, platelets, and then 5 different types of white blood cells. All right. Questions on making blood cells? Our red blood cells are born, they're also going to die. On average, they live about 120 days, or 4 months. Without a nucleus, they can't express genes to make new proteins to fix themselves. And as they bounce around in the circulation, they gradually accumulate damage. Then they get broken down by macrophages, big eaters, cells that clean stuff up, found mostly in the spleen and the liver. And then the hemoglobin is the main thing that needs to be dealt with. It's taking up 1/3 of this cell volume. So it gets broken into 3 parts. The globin gets broken up into amino acids, which can be used to build new proteins. The iron gets reused to build new hemoglobin in new red blood cells. The heme portion gets turned into something called bilirubin that gets excreted by the liver in body. If the liver can't get rid of all of it, then it can accumulate in the skin. Bilirubin is yellow, so it makes you turn yellow, and it's a condition called jaundice, which means yellowing. So, question on red blood cell breakdown. White blood cells there are 5 types. They're divided into 2 categories called granulocytes and agranulocytes. Granules are little grains or specks in the cytoplasm. Granulocytes have them, agranulocytes don't. There are 3 types of granulocytes. Their names all end in "phil." They're called neutrophils, eosinophils, and basophils. Agranulocytes, there's 2. Their names end in "cyte." That's monocytes and lymphocytes. Neutrophils are the most common type. They make up about 60% of the white blood cells in any sample. Phil, if you remember from hydrophilic, is that it likes something. There's a bunch of different stains that are used together on blood samples when you're going to preserve them on a slide. The neutrophils like one that's neutral in pH. It sticks to them. It's purple. It sticks especially to the nucleus, which is really weird. It's not round. It's clumped up into different groups called lobes. And then there are some speckles scattered around, and those are the granules. The job of a neutrophil is phagocytosis, eating things. Neutrophils respond quickly to an infection, and they come and eat up the damaged cells and the invaders. But once they start, they only live a few days. They basically gorge themselves and die. So here's, let's say you get a splinter. The neutrophils come to the scene, and you can see them here gobbling up some bacteria. That's phagocytosis. Eosinophils, they like a stain called eosin, which is red. So most of the pictures, they're going to be bright red or pink. This picture is detailed enough that you can also see the red is speckled, and that's the granules. On our slides, they're a pretty pale pink. What makes them distinctive is that the nucleus still has lobes, but usually just 2 of them. So it might look like one of those classic green aliens, except that it's red. Eosinophils fight parasites, especially worms, and they reduce inflammation. Eosinophils are pretty rare. They only make up 1 to 3% of the white blood cells in a sample. Basophils are also very rare, typically less than 1%. That's because their job is not in the circulation, but out in the tissues. The name basophil means that they like a stain that's basic or alkaline. They have big purple granules that fill them up. Sometimes you can't even see the nucleus. A basophil's job is to attract others to an injured area. They release histamine, which causes inflammation. And we'll talk more about inflammation in the immune system, but basically it sends more blood to the area. and heparin that keeps that blood from clotting. So more white blood cells can get through to heal it. Questions on granulocytes? Your agranulocytes, monocytes are bigger than the rest, about 2 or 3 times the size of red blood cells, where most of the others are just a little bit bigger than red blood cells. They have a large nucleus that's usually bean-shaped, but sometimes it can be round or more U-shaped. Monocytes are more common than eosinophils and basophils. They'd be somewhere in the 3 to 9% of a sample. Their job is also phagocytosis, like neutrophils, but what they do is they go into the tissues and they develop into a macrophage, which we mentioned before, the big eaters,